Hey, so welcome to using take damage on actors. In this video, what we're going to do is starting to take damage. So if we look at this tank and we see that in the inspector, we now have a current health value that we can read but not change. And every time we get hit, it goes down 20 and eventually our tank can report as dead. So let's get it done. So I want to start by making a couple of tweaks to this projectile. I want to get rid of that brown ball. It seems to have crept back in for me. And that's probably because I have at some point on the collision mesh part of the projectile blueprint gone in and made it invisible, but perhaps not saved my blueprint. The other thing I want to do is increase the radius of my explosion force. I'm going to do that up to 10 meters, 1,000 centimeters, simply because it's quite hard to actually make the other enemy tank appear to be hit. So let's just try that with a 10-meter explosion radius. That's good. That's easier to hit him now. So you can constantly, as you go through the development of your game, of course, tweak these parameters as soon as you find out that they're not how you want them and make them better. Okay, so now on to the issue at hand, which is that when we hit the enemy tank, another thing that we want to do is we want to actually go in and apply some damage to him. Just before we set the timer, I would have thought the timer ought to be the last thing we do, the destroy timer, just because it feels like we finished with the hit then. But just before that, we want to damage the enemy tank. So I'm going to start this off, get you going with how to use the Unreal Actor damage system, and then you can go ahead and finish the damage system on the tank side. So what we can do from here is we can use something called uGameplay Statics. And there's a method on uGameplay Statics called apply radial damage. And that goes very nicely with our explosion force that we're already using that is radial. So let's go ahead and open up that method. Great, so what does it need? Well, it's going to need a few things. It's going to need a reference to the context that we're going to apply the damage from, which is this projectile right here. We need a base damage amount. So on the projectile, I'm going to make ourselves a damage amount. So I'm going to put it here. I'm going to make it a U property. I'm going to make it edit defaults only. I'm going to make it category equals, what should we have? Components firing setup. I think it's still the setup. And then the deal is it's going to be a float, which is talking about the projectile damage. It's a set an amount of damage that this projectile does. Whether it should be a float or an integer is for discussion in a way, but if we look over here in the signature of this method and what it's expecting, it is expecting a float. So as soon as Visual Studio catches up with me, we'll see that it wants a float, so let's give it a float. We'll talk about floats and ints and damage and actually getting to zero damage when we get to the other side, in fact, in the solution to the challenge. So it wants a float, we're giving it a float, let's call it projectile damage, there we go, and that is editable. It then wants an origin of this damage. Well, we just get the actor location. We are already in the projectile, which is the actor in question. That is where the damage is going to start from. Now, the damage radius, what we can do here is we can look through the explosion force to its radius and just use that. Then we have bound these together for consistency. Yeah, that's pretty handy if I've spelled consistency right. Doesn't really matter if I haven't. But the idea is that if we change the explosion force in the blueprint, then this will come through here. That's pretty handy, right? Now we need to give it a uDamage type. That's the next thing. So let's do that. uDamage type, : : and we're going to use static class here. If you want to find out more about that, then go to the documentation and read read about the apply radial damage method, which we can look up as follows. I'll put this in the resources for you as well. uGameplay Statics apply radial damage. There you go. It's giving you all sorts, big ugly signature, and down here gives you some more information about what each of these mean. Okay, I'm just giving you the solution, if you like, on this side, and your challenge will be on the other side. This is how we apply the damage in the first place. Then it wants an array of actors that are going to receive the damage. Well, we want an array of actor pointers, like so, but we're going to give it an empty array, i.e. we're going to ignore, or damage all actors is easier, damage all actors. Okay, so that's what we do on this side. And then all actors that are within that radius are going to receive an amount of damage that's determined by the projectile damage. So that's one half of this done. Then what we need to do is flip our attention over to the tank. And yes, we're actually going to use the tank. The tank is not a completely and utterly thin and useless class. Now, because the tank is an actor, there is a method that will be called on the tank automatically if it's in that radius. And that method is this actor take damage method. And there is the signature for you. And what I want you to do is take on the challenge of trying to implement tank damage. So take a look at that actor take damage method as linked in the resources, or just Google search for it. Override the method. The tank's it's a virtual method. We've done this before, virtual void override, all that sort of stuff. Although it's not void actually, so it's virtual float override in this case. Clamp the damage to apply to the current health. So inside we'll have something like damage to apply equals, the damage that comes in, which is called damage amount, as you can see in the signature. And we want to clamp that to the current health. So say the tank had, as I said before, 10 points, 17, let's say, points of health left, and the damage we want to try and apply is 20. We actually only want to take 17 points. We want to have health end up at 0 precisely. But all you need to do for this lecture is log the damage amount and the damage to apply. So it's really about just overriding that method and doing a clamp, and then log these values out to make sure that the damage amount and the damage to apply look like they're right. You can tweak the starting values if you need to check the clamp, and then either carry on watching this video, or if you feel confident and this challenge is too small for your level of experience, then just carry on and finish the entire damage system. Without the UI, I'll be covering the UI of the damage in the next video. So go ahead, pause the video and take on the challenge now. Okay, cool. So let's go and have a little look at how this is going to work. So on the tank, we are going to need a few new things. Firstly, we're going to need this method. So here it is. Here is the signature of it, virtual float take damage. So what we do, as we know, is firstly decide whether it's public or private. Well, it actually needs to be public if you think about it, because other classes need to be able to call this. So take damage. Now this leaves the responsibility for taking the damage in the hands of the tank, which is fine. It doesn't have to take damage, but it can decide whether it's going to take damage. But this method will get called by the engine when something like this projectile is in range and says that damage should be taken. So all I'm doing here is stripping the white space on this guy, popping a override on the end of it, and that's it really. So I've literally just copied that from the documentation. So we have that public method there, and I think I'm going to put a comment to say called by the engine when actor damage is dealt. Okay, fantastic. So I've got the signature. Let's go ahead and just do the implementation of that now. We don't want the word virtual. It's a float. We'll need to take note of that in a minute, that we have to return something. We have to put the class name in. We strip over right off the edge and switch into curlies. Okay, so that is the beginnings of things. Now, we need to return something. This wants us to return the amount of damage that was taken, and in the challenge slide I said we should call that damage to apply. So let's return damage to apply, and let's also immediately calculate damage to apply. So use auto for now, and damage to apply, and then we're going to use the clamp, fmath clamp. And what we're going to clamp is the damage that comes in here, which is the damage amount, and we're going to clamp it between 0 and the current health of the tank. Now we don't have a current health, so let's go and give ourselves a property in the tank down here in the private section. Because it's a variable, we want to keep it nice and private. Private current health. Now, what is the value of current health? I'm actually going to specify health in integers. I'm going to go straight to that because we don't want to be dealing with comparing floats to zeros. Remember, we've talked about this before. So I'm going to do the following. I'm going to say we have two int 32s. One is the starting health, and I'm going to give it a sensible default value of 100 like that. And then I'm going to make a current health, and I'm going to say that that's the starting health. And we can do that in the not in the constructor, but in the header file here, because we know the compiler knows the starting health, so therefore it can know the current health. Now, while I'm at it, let's make these things uproperties. And this guy, the starting health, is going to be edit defaults only, and the category is going to be setup string referenced. Okay, then the starting health. Sorry, the current health. Well, it's going to be uproperty. It's going to be visible anywhere, because we don't want to be changing it. It only wants to be changed in code. And category equals, I'm going to say health. Okay, so hopefully that's clear what we're doing there. We have a starting health and a current health, which means that over here we can clamp the damage to apply somewhere between 0 and the current health. But we don't want to ever be comparing floats to 0. So what I'm going to do is I'm going to start off by saying, actually, let's introduce a concept and be explicit about the type now. We want an integer concept of damage points, which are going to be an integer there, a number. And then what I'm going to do is I'm going to use F-platform math. Has a method in it called round to int. And we're going to take the floating point damage amount that comes in. We got no control over that. It has to be a floating point. And we're going to round this damage amount that comes in into damage points. And then when we talk about the amount of damage we're going to apply, we're going to actually use these damage points. And then the auto here should come out as an int 32. In fact, I'm even just going to be explicit about that. So I'm saying, let's convert floating point damage to integer damage. Let's round the damage to the nearest integer, and then decide on what the damage to apply is as an integer somewhere between 0 and the current health. And remember that it's all in integers, the current health and the starting health. Hopefully that makes sense. If we do that, then life is going to be a lot easier because we can say for sure that the tank has exactly 0 health. So we're nearly there with the challenge now. All I want to do is log, warning and text, and I'm just going to say tank, or just say the two things I wanted you to log out, which are the damage amount and the damage to apply. Okay, so damage amount equals %F, damage to apply equals another %F. And then we literally just lay those out. In fact, because I've named them precisely what they are, I can just copy and paste there. And we're good to go. And we have to return a damage amount. So hopefully this makes sense. Let's see if it works. I'll show you the source control while we go. So this is my declaration. In fact, it's missed something there, and that's because I'm showing you the wrong file. There you go. This is what we've done in the tank and header file, and this is what we've done in the tank C++ file. Not going to show you the full lines there. They're very long, but there you go. Okay, hopefully the compile has happened by now. Let's see if it was complete. 19:01 p.m. which it is in my local time. So that is, by the way, a way that you can tell whether that has worked. Now, let's see if the log, I need the output log available. And right down at the bottom, in fact, I'll clear it. Let's just see what happens. So we're not actually subtracting these things right now. Damage amount 0, damage to apply 0. Okay, so that's just probably because in the projectile header file, where we had projectile damage, we never actually gave that a sensible default. And this is the importance of giving it a sensible default. So projectile damage equals 20F. Let's recompile. And when we recompile, why don't we just go ahead and have a look at the projectile and make sure, well, let's just see where this is going to be. It should be on the projectile. We should have edit defaults only. Yep. So let's make sure that on the projectile, when we find the damage, that this actually comes in as 20. Now, it hasn't there. What's the problem? It's probably something simple like the F suffix on projectile.h. So that's because I've said 20F without a 20 decimal. So I need to put the decimal in there. Okay, let's just recompile. And what we're hoping will happen here on the projectile blueprint is that you will see here it jump from a default of 0, which is why 0 damage was being dealt, which is the default if you don't specify a value, up to 20, which it has there. And now the designer can take it from there and improve the value. So let's see if this is doing what we want. Just going to go F8 into the output log. Yeah, so we're getting a damage amount of 20 coming through, so the message is being called, which is good news, but the damage to apply is coming out as clamped to 0. So what is wrong with the way that we're doing the damage to apply? And in this case, it's not because there's a problem with the value, actually. It's because I'm using the wrong format operator. It should be %i for integers, and you will not show a floating point properly. It will not make the conversion for us. So we have to be very explicit about what types we are expecting here. So we're saying damage amount equals %ish, damage to apply equals %i. I wanted to show you that because you can believe what you see in the logs sometimes, but actually what you're seeing in the logs is wrong. I should see 20 for both values here because there is no clamping to be done. That's good. So we have the fundamentals of the damage system in place now, which is great news. To finish that damage system off, all we have to do is when we get this damage, we simply have to say that the current health minus equals damage to apply, like so. And then what I'm finally going to do is just use this log entry to say if the current health is lower than 0, or lower than it, less than or equal to 0, not that it should ever get there, then we're going to log out that the tank is dead. So instead of all that stuff, I'm just going to simply say tank died. We could say which tank if we wanted by getting names and things, but for now this is perfectly okay. And that's it. This is a very simple and very standard damage piece of code. So let's just make sure that that works by compiling. We'll play the game, we'll inspect my tank. On my tank, we should be able to see the current health value decrease from 100 down to 0, and then eventually we should get a log entry to say that my tank is dead. So I'm going to F8 to depossess, inspect my tank, go to the details, then have a look at the tank and find the current health. You see 80 there, that's looking good. 60 as it gets hit again, 40 as it gets hit again, 20 as it gets hit again. It missed that time, hit me the final time, and tank died. And when tank dies, we need to do some other things, which we'll cover in the next lecture.